Hi everyone, let's go ahead and get started with the building RAG locally with the DeepSeek for financial data analysis. In this lesson, I'll be showing you how you can make here a Streamlit application. This is going to be a very beautiful Streamlit application in which you will be having your PDF document preview at the left side, and at the right side you are having your Streamlit application. It starts with the title, and thereafter here you can select all the PDF document which you have ingested in your database. So what's your database? Here is your database FAISS and the Chroma vector database. You can get that from the drop down list, and if you have a new document, then you can select here new document to upload a new document. Once you process your document, then that document is stored permanently in your computer, so that from the next time you do not need to process your document again. Thereafter, here you can enter your question and then you can submit your question. And behind the scene, we are running here Ollama, and along with the Ollama, we are running there a DeepSeek-R1 model. So DeepSeek-R1 model, let me just quickly show you. This is a very famous model, and currently I'm using a very small model, that is DeepSeek-R1 1.5 billion model. If you are new to DeepSeek-R1, it is pretty much simple to work with this. You need to just install the Ollama. Thereafter, you just need to import this DeepSeek here. You can just run here like Ollama pull and your DeepSeek model. Thereafter, you can use in the code that I'll show you later on. Other than that, you can watch my previous videos. For this, I have already provided the link in the code, and you can get the code from my GitHub repository at Lakshmi Merit. And then here inside the repository, you must be seeing there a repository Ollama chatbot. So this Ollama chatbot provides you all the code which we are currently using in our current lesson, that is here build financial document analyst with the DeepSeek. All right, and inside this you have app.py, and then you have here rag.py, and this is where your document processing is done. Basically, this is where your processed documents are stored. So you have your FAISS database here, your images are stored here, and your PDF document is stored there, whatever the PDF document you upload here. Thereafter, you can simply ask the question, and then your model will start generating the question through the RAG. So in RAG, what happened here? We have already ingested our document that I'll show you later on in the code, and then here through this database it fetch all the matching chunks, and then it passes this question and the matched chunk to the LLM, that is going to be the DeepSeek in our case, and then it generates here a final answer. As you can see here that it has generated here a final answer. It says that okay, these are the things here. All right, now let's go ahead and get started with the coding part, where I'll be showing you how I have coded this Streamlit application and what is the RAG system behind the scene. Having said that, let's go ahead and see how this overall application is made here. So what I did here, first of all, I decided to make a document ingestion in one part, and then I stored that whole thing into our rag.py file. So that thing I have stored here inside the rag.py file, and in the rag.py file we have multiple methods, like we have load and convert documents, get markdown splits, and then create or load vector store, and then build RAG chain. Let's go ahead and see inside each of these methods, and then I'll explain you what this thing is doing. Let's come back to again here in the description part, in the architecture part. So this rag.py part, what you see here, what happened here in the rag.py, it reads the document. It reads this document using the dockling library. So this dockling is very helpful library. Then this convert PDF document or any kind of document, in fact, you can upload. But as of now, I have chosen here just a PDF. You can convert that into a markdown data, and then that markdown data can be splitted with markdown splitter as smaller chunks, and then that we can actually store into a database. Currently we are using here FAISS database. Other than that, this whole process I have covered in my previous lesson, where I have talked about this whole thing in the detail, and I built there this whole RAG using this notebook. But this time I'm building it using a Streamlit application. And the Streamlit application I have already uploaded here at Lakshmi Merit Ollama chatbot. You have here app.py and the rag.py. So this is what I'm currently explaining. All right, let's go ahead now see the whole thing again. So here load and the convert document. Inside this you have a document converter dot convert, and then finally it exports this whole PDF document as a markdown data. Here inside the import you will notice I have imported this document converter from the docling document converter. So this docling is actually the PDF library. It is like a document converter library which converts any document into the markdown or text data. Once it is converted into a markdown, thereafter I use here get markdown splits. So in that what happened here, I split that data into a smaller chunks. So this is what you see here, a smaller chunks that gets converted. And thereafter I use here create and load vector store. So this particular thing, what you notice here, that this whole thing is being used here to create, I mean, this whole thing is being used to ingest our all the chunks into our vector database. We are using here a FAISS vector database that you can see here. So this is the FAISS vector database which we are currently using, and inside this we are using here embedding and then in memory doc store and all these. So from where this embedding and other things are coming, that is coming from here build rag chain. So inside the build rag chain we have here a simple prompt. Inside the prompt we say that you are assistant for a financial data analysis. Use the retrieved context to answer the question. If you don't know, say so. Otherwise use bullet points to provide the answers clearly. All right, then you have here a question and thereafter you have here answer. All right, let's go ahead and remove this so that we can get the answer as per the asked question. And thereafter here you have prompt template. All right, and then here you have your model DeepSeek-R1 1.5 billion model. This is very small model. This type of model does not need a GPU. You can run this model on a CPU as well. Thereafter here I create a complete chain, and in this chain this whole things happens like get the retriever and after do the the document joining together so that you can create a final context, and thereafter you can provide your question and then provide a prompt template so that using this context and the question you can prepare a complete prompt template. Then you create here a model DeepSeek, and thereafter you finally do here str output parser. So this thing, if you notice here in our the architecture, so that thing is particularly this one. All right, so this is where this chain is being used. So this is whole chain where you pass this question and thereafter this becomes as a context, then this whole thing you pass here. All right, so what you see here, this and this is implemented in the rag.py, and the sum part of this is implemented in our Streamlit application. And here is our Streamlit application. So this Streamlit application, you will notice here the two things. So the first thing you will notice here that let me just open this, then I'll explain you here. So this thing what you notice here, this whole thing is actually a PDF viewer. All right, other than that you will notice here this one is our heading, and here I provide a drop down list so that I can find out that how many documents are already processed and it is stored in our local computer. And thereafter this what you see here, this is where I ask a question, and once I ask the question, thereafter I click the submit button and then the final answer is printed here. When I click on a submit question, then what happened here, whatever the question I have here, this question goes through the process with the process which we have seen previously. So this question goes through the Ollama embedding. It find out all the matching context here, and thereafter this question goes here and along with this context to the our rag chain, and then finally it creates the final answer there. All right, perfect. Now let's go ahead and see the Streamlit application code. Again, I'm telling you this whole code is available at my GitHub repository. Don't worry about that. You can just go there and follow along with this. So here you have all the necessary libraries which I have imported here. Let me just collapse this whole thing so that you can know at a high level that what are these things. So you have, we have imported here all the necessary library here, like import OS. In this import OS, we have Streamlit application, we have here a pathlib, and then all the methods from the RAG we have imported here. And then the Ollama embedding, FAISS vector database. So these things will be used here to work as a retriever, because I told you previously that some part of the retriever is actually prepared here in app.py. And this particular library is used to convert our document into the images so that we can display our document here at the left side and along with your application, so that you can have a reference of your document and you can ask the question. All right. Thereafter, this is where we are going to store all the process document that is going to be inside the vector DB. I have here a vector DB and I have already processed Google document. So because of that, you will notice here the one thing you have here image. All right. So there is the file name, and inside that you have here an image, and all the images are stored here inside this particular file. Now you will notice here all these images for each pages are stored here so that we can display that with the application. Thereafter, this is where this FAISS, the vector DB is stored, and thereafter you have your document that is stored here. So whatever the document we upload in our Streamlit application, for a simplicity, that application stores our document inside the vector DB with the file name, whatever the file name is there when we upload it. All right. Thereafter, we have here app.py, and then we have here rag.py. So rag.py we have already seen. We are seeing app.py. Thereafter, we get here a display PDF in the sidebar. As we know that we have all the images stored here. So this whole thing is done inside this display PDF in sidebar. We provide this into a try and accept block. So first of all, what we do here, we try to find out there if this particular image directory is available so that we can directly read these image. Basically, what I do here, let's say if this particular document is already processed, then there is no need to process it again. So what I do here, I store the whole image inside the directory so that the next time whenever I ask a question, then it just goes here and read the image instead of processing that every time whenever I ask a question. So that thing is done here. Thereafter, you have image path. All right. And this is where you have image path, and then it checks that if image path is thereafter it reads all those individual images and then it displays that into the sidebar. Thereafter, you have here else. Inside the else, what happened here, it convert all the PDF document. All right, basically what this particular thing is doing here, if suppose that image is not converted, so what I say here that if PDF document is not converted as image, then what it does here, it convert all the PDF pages into the image. So this is a library which we are using, convert from path, and that comes from PDF to image library. Then this library converts all the PDF pages into the images, and then that image is stored here at this particular path. So that path is actually used here, image path.png basically. All right, and thereafter finally we display everything in our Streamlit sidebar. And here are the exceptions. So if anything happens, basically if PDF page count error or any kind of the error happens, then we throw the exception. All right. Thereafter, we have our title here, build RAG locally with the DeepSeek for financial data analysis. So what you see here, that this is what you have here. All right. Thereafter, you have a drop down to select vector DB or upload a new document. So basically, this is where we upload our document. So I have provided here a very smart way. I have provided here a mechanism in a very smart way. So if you have already uploaded any kind of the document, then you do not need to re-upload that. Otherwise, you can re-upload a additional document. For example, let's say if I want to upload some other company's document, then I can just click on upload new document and then I can upload. Otherwise, I can just come here and reselect my Google document again here. Now you can see here that this document was already processed. That is why I can see here at the left side, this image is displayed immediately. Now I can start asking here question. All right. So this is where I provide all those options there. Then I say here, okay, If I select upload new document, then provide a mechanism here to upload a new document. So when I upload a new document, there is a lot of processing which I do, because if there is a new document, then I have to go through with all these process again. What I see here, that like upload a document, then extract the data, then do the chunking, and thereafter store that into a vector database. Once that is stored into the vector database, thereafter I can start getting the list of that particular DB here. Let's go ahead and just try out that. So I click on upload new document, then I click on browse file. Then here what I do here, I have some document here. Let's say I have here a finance document. So I already have for Google, I'm going for the Amazon here. So I select here Amazon. Now you can find out that here. Okay. So this document is selected. It has started processing here. In some time you can see that that document will be displayed here at the right side. And then here a button which will be displayed so that we can process the document, and then we can convert this document into the vector space. So basically this document will be stored into the vector DB. As you can see here that this document is processed. Now you can see here all the images. All right. And it has so many pages. That is why it took some time. Otherwise, it could have done it immediately. And depending on your computer speed, it might take some time. Thereafter, you get here process PDF and store in vector DB. Now I click on this. Now it is going to convert this everything into a vector DB, and then it will store that into a vector DB. Earlier we had only Google, and now we are having here Amazon. Inside the Amazon we have all the images here. All right. So what happened here, each of the page gets converted as PNG image, and then those images are stored here so that the later on we can directly display those into our Streamlit application at the right side. All right, thereafter we scroll it down here. Thereafter, what happened here, you can see a temporary document is also created here, and this is used for the processing. Okay, in some time we will be seeing here additional Amazon the folders for our FAISS vector DB, and also this particular PDF will be moved inside the vector DB. Now we can come back here. We can still see that it is processing the document, so it will take a time, because depending on your computer speed, it might take some time. Now you can see here that additional Amazon folder is created here. A FAISS DB is also created, and then a PDF that was here, now it is moved with a proper name inside its vector DB folder. All right, now I come back here to the application. It says that, okay, the PDF is processed and it is stored in the vector DB. Now from the next time, I do not need to process this PDF. Thereafter, if you notice here, if I just, do something like this, although I cannot see that as of now because the refresh has not happened, but do not worry about that. But just let me ask here the question, what is the revenue of Amazon in 2024? All right, let's say I ask this particular question. Now it is going to basically it is going to retrieve all the matching context, basically all the matching chunks, and then it will combine all the chunks together along with this question, and then it will call the RAG chain, and then it will produce the final answer. Now you can see here that this answer your question is being done, and it is generating the answer in the runtime. So DeepSeek have a reasoning capability. So the first of all, it provides here a thinking step. After the thinking step, then finally it produces the answer. So that answer, we can see here that answer is being generated here for this particular document. Now, if you check here the select DB or upload new document, so basically you can see here, now you have got Amazon and the Google. Now, if I ask again this particular question, it is not going to take a lot of time. Why? Because the whole processing is already done. All right, I can see here that these two document vector DB is already stored and everything is done. So whenever you are designing a system, these kind of steps are very important, right? So unless you implement a system something like this where processing is fast and it is optimized, then unless you do something like this, otherwise your system will not be optimized and it will take a lot of time, and unnecessarily it will consume a lot of the data and processing power. All right, having said that, let's go ahead and see how this generates the answer. So in app.py, we will again come back. We have seen that what we do after we upload the file. So this is the whole thing, what we do after uploading the file. All right, so we process the document, we display it into the sidebar, and then finally we also show there a spinner that this is being done. So now you remember that there was a processing document. So these are the step which is being done there. As I told you earlier, that get markdown content, chunking, embedding, vector store, all these things happen. And thereafter finally that temporary file gets deleted, and then we saw that this Amazon PDF was inside this vector DB. So this is whole thing what happened when you upload a new file. Now let's come back to the selected vector DB. Now what happened here, if you select a particular vector DB, then what happened? That means what I'm saying here, that apart from this upload new document, if you select any of these things, then in that case what happened, because we have already created our vectors here and PDF documents are already present and images are also present there, so it will automatically go and read these vectors and it will not do this whole processing again, because those things are already present. So basically it will come here and it will read all of those things. So that thing is being done here. So basically I provide here embedding so that I can, this embedding is necessary to get our vector store. So basically we are loading here. Earlier we were storing here, right? Save local, but this time we are loading our vector DB and we pass that embedding so that we can get the embedding of our query, and then we can match it through the cosine similarity. Thereafter we process our PDF images and then we show that image into sidebar. Thereafter we provide here a final question. So this is where we ask the question and then a person submit the button, and once person submit the question button, and then it will start the processing your query. So basically it passes your query through the retriever and then it passes to the build RAG chain, and then in the RAG chain we do here a streaming. So basically through the streaming what happened here, our response is going to generated here in the form of the chunks here. All right, and then we replace our dollar with the double backslash dollar so that it does not it does not process our dollar sign as the latex mathematical formula. So this is what we do the whole thing. All right, all right. Now let's go back to our application and then see how this whole thing is being done there again. So I come back to my application again, and if I refresh it, you will see here that the same thing. All right, we have our images here at the left side, and at the right side we are having our application. Now let's go ahead and test our RAG with some other kind of the question. As we scroll it down, we can see all kind of the document here, all these things are here. Let's say if I ask some kind of the question related to this PDF, I'm just trying to figure out that what type of question I should ask here. That let's say I ask that what is revenue source for Amazon. All right, let's say if it is able to answer this. So it should be able to answer, but working with the RAG is not that much straightforward. This is one of the simplest way to implement the RAG. But generally in RAG, what we need to do, you ask a simple question, thereafter there has to be reformulation so that you can reformulate your question properly along with the matching content so that it can provide a proper output. Otherwise it is not that much simple, but we are working here with the DeepSeek. I'm showing you how you can implement on local computer, so it is fine. All right, so here it is asking, it is thinking, and thereafter it is just planning out that. So in summary, it says that while the primary revenue for Amazon comes from its product and services sold directly to the consumer, it generates through etc etc, and there are so many other stuff. So it didn't tell exactly from where this whole thing is coming, but overall it says that from the technology, API, cloud, and from so many other places it is coming. Let's say if I ask that how much revenue was generated from AWS services, it should be able to answer this particular question as well. But do remember here we are using one of the smallest models. We are using here a DeepSeek-R1 1.5 billion model. That is the one of the smallest model. So sometimes reasoning capabilities and generation capabilities of that particular model might not be as good as the OpenAI models. But by seeing that that is very small model, I mean, overall, we are pretty much satisfied with the performance of R1 model. I mean, R1 1.5 billion model. So here now you can see that it is providing all the thinking process, and then it says that here is the things. All right. Although it does not say exactly how much it got, but yeah, here in between somewhere it has said that okay, these were the numbers, but I see that it could not find out the exact number here. All right, let's go ahead and just change this. How much revenue was generated from AWS services in September 2024? Let's go ahead and see if it is able to ask this question. So working with the RAG, I mean, asking a very good question, I mean, asking a right question is very important while you are working with the RAG. All right, so it has started generating the answer. Now it says that, okay, here is the North America, then international, AWS, and there are so many other stuff. Now it has started finding out all the numbers, and I'm sure finally it will provide us the final answer here. Now you see here that asking a correct question is very important while you are working with the RAG. A question might not generate the answer, but with a little bit reformulation, it might provide you a correct answer. Now we can see here that all these answers and these things are pretty much straightforward and very much clear here. I hope that now it is pretty much clear to you. You can select here other document, and you can ask, I mean, you can thereafter upload a new document, anything, whatever you want, you can do that. Let's go ahead and upload other documents. So those documents you can also do. As of now, let's say if we select here a Facebook, you can do that as well. Or you can say that something like this, or any document basically. All right, something like that. This kind of the document you can select, and then you can see here, okay, this is the document. Then here you have earning script. Basically this is the transcript, while someone, I mean, I think the CEO or someone from the Meta was presenting its revenue and its financials output at the SEC. So they were addressing the media, so they were talking here. So the question answer sessions was done. So you can ask the question from this particular the question answer session as well. You can click on the process PDF. You should be able to see that that is here generated. All right, perfect. Now I hope that this is pretty much clear to you. The code for this particular file is available at my GitHub repository. All right, let's just push this at my Git repo. You should be able to see it. Let me just push it here. Now you can come at Ollama chatbot, and in Ollama chatbot repository, here is the section that is build financial document analyst with DeepSeek. All right, and there we have our Streamlit application. It is pretty much straightforward. What you have to do there, you have to just simply come inside app.py, and this is where you are going to actually run your Streamlit. So basically you have to just run here Streamlit run app.py. Let me just write let me just write that here so that you can know that what you need to do here. So you can say, okay, Streamlit run app.py. You have to make sure that you are here, and then you just simply run this. I hope that this is pretty much clear to you. This is all about in this lesson. I'll see you in next one.